Today we're building a custom rear suspension for my 1964 ERA Shelby Cobra. And we'll be starting with this and ending with this. Let's get started. All right, so the first thing I'm gonna do is separate the top from the bottom of this cradle, this aluminum cradle for the suspension. And I'm gonna install that differential that we rebuilt last weekend. There's a bunch of little bolts that hold the top to the bottom. There's about 3 or 4 on the back, 3 or 4 on the front, but right now I've only got 4 of them, so I'm just gonna go ahead and take these out.
Okay.
And there we go. Both halves are separated. We've got the top and the bottom. Now what I gotta do, bring the diff over, put this on top. There's 4 bolts that screw into the top of the diff and mount this. And then I can flip it over and mount the bottom to it. And there's 4 bolts that come into the side of the diff. And then obviously the small bolts come back to mount the 2 pieces together. And then I have a whole cradle ready to start building out my suspension. All right, here's the differential from last week. Let me grab the top. I'll slide it on, put the 4 1/2-inch bolts in the top, cinch it down, and then we can flip it over and put the bottom cradle on. All right, so we got the differential installed into the aluminum case. I've got it flipped upside down, so now I can put the base on and put the 4 bolts into the side and the retaining bolts for the case. Let's do that. All right, everything looks lined up. I'm gonna put the 4 bolts into the side and then the front and back bolts. All right, let's cinch down all the bolts and then we can call it good. All right, got all the bolts tightened up, the top 4, the side 4, and all 16 of the smaller bolts that hold the top to the bottom. So now we have a whole cage ready to start building off of. So now what I'm gonna do is I'm gonna take measurements of the lower mounting points for the control arms so I can start fabricating those and making them to meet up with the hubs. So we'll move on to that. All right, let's start making these lower control arms. The first thing I'm gonna need to do is start taking some measurements. So I need to take a measurement off the mounting points on the inside of the cradle, hub width, and then I'm gonna need the final measurement, which is the measurement from the inside mounting points to the hub pivot point. Now that measurement is provided by ERA through their manual. I know that's 16 inches on center from the mounting points on the inside of the cage to the pivot points on the hubs. And then I know now that I've measured the inside and outside what those measurements are. So now I can make my jigs. So to make my jigs, all I did was just use some 2-inch wide flat plate that I got from the local hardware store. And I ordered these off of Amazon. They're just little brackets with a 1/2-inch hole in them. And they come in like packs of 20 or whatever. So I just drilled the hole out for the 5/16 bolt that goes on the inside mounting point and the 3/4 inch bolt that goes on the outside pivot point. So now I'm basically able to make my jigs. Now that I got all my measurements and everything's drilled out to the sizes they need to be, I was able to find the center point on my 2-inch plate and then weld on my little brackets to make my 2 jigs that I'm gonna use to make my lower control arm. So now I have a jig for the inside and the outside of the lower control arm. Now I just have to set the distance between them, the 16 inches on center distance between them. Now I'm using this Strong Hands Rhino Cart fabrication table. So this is the Rhino Cart I'm using. Obviously you can see it has 5/8 holes with a 2-inch hole spacing. It's mobile. I bought it with the accessory kit. There's a lot of accessories, and as you see me build this lower control arm, you're gonna see me use some more of them, like the hole notcher and some of the other features. It's a super awesome tool. If you're a fabricator, I highly recommend it. All right, so now that we know that the fixture table has the holes that are 2" on center, I can just mount my inside bracket, measure 8 holes down, and mount my outside bracket, and I know it's 16 inches on center. So now we can start building out our lower control arm. So the heim joints I'm going to be using are from FK. They're the HD series FK rod end heim joints. They're 5/8 on the inside and 3/4 on the outside. Now you'll need to buy the lock nut and also tube ends for the joints. So the heim joints I'm using have a 3/4 inch shank on them, and the rod ends I'm using are for a 1 1/4 inch 120 wall tube, and I'm using chromoly tubing. Now when you initially set these up, when I set these up in the brackets, what you want to do is go ahead and just pre-set these up, screw them on, screw the rod ends onto the heim joints. Now there is a recommended thread engagement for these heim joints to maintain the strength, right? So with a 3/4 inch shank, it's different depending on what size the shank, if it's a 1/2 inch shank or whatever. You can look up those, what those requirements are online, but for a 3/4 inch shank, I have to have about 1.25 inches of thread engagement. So then what I did was, well, whatever thread was remaining, I divided that in half. So that way it'll give me adjustment inside and outside and still stay within that strength rating, right? So what it ends up being is I have about a 1/4 inch of thread left exposed, and I'll just make sure I set that on all my heim joints. Okay, I have all my heim joints installed on my brackets, but you'll notice on this back bracket, or actually it's the outermost bracket, I have an adjuster. And this adjuster I'm going to use so I can adjust my toe on my outside, which once I get this completely built, I'll be able to show you that in more detail. But I added this again, so while everything is installed, I'll be able to adjust the toe on my rear hubs without having to take anything apart or do anything like that. All my heim joints are installed on the brackets. So now I'm just gonna take these accessories I got here from my table, try to level out these as best as I can, and then I can just take a measurement, which this looks to be about 5 1/16 of an inch, and cut my chromoly tubing, and then I can weld these on. So I'm getting ready to cut this chromoly tubing, and I just want to show you the piece of equipment I'm using. It's a Bailey's BS 128 bandsaw. It's obviously portable. I mean, I'm working out of a 3-car garage, so that's sort of a recurring theme around here. Everything has to be portable so I can bring it out, use it, and then stow it away. So let's go ahead and cut this tubing. So it cuts nice and straight, good cut. So now what I'm gonna do, I'm gonna sand this tube down completely so I can weld against it, get a good clean weld. Let's go back over to the bench. Okay, you can see now I got all the tubes cut to length. They fit perfectly. I've sanded all the coating that comes on these chromoly tubes off. So now I'm down to the bare metal. And I've also put a beveled edge on the tubing, so I know I'm getting good penetration on the rod ends. So the next thing I'm gonna do is weld up these rod ends to the rods. So just be aware, and I learned this the hard way, You'll want to put some sort of ground on this, even though this is grounded to the table, because these rod ends have a Teflon liner in them. So what'll happen is when it tries to ground and you start to weld on it, it's going to arc across the bolt to the casing, and it's going to end up marring and messing up this rod end. So I went through a rod end doing that. Anyway, make sure you ground this, put some tacks on it, and then remove all these, because like I said, these are Teflon and there's grease in there, and you don't want this to get so hot that it just boils the grease and the Teflon out of the liners. So we'll just put some tacks, make sure everything's good to go, take it all apart, weld it all the way around, and then put it all back together. Also of note, so if you're wondering what welding equipment I got, I'm using the Miller Multimatic 220. I just got it last year. I was using the Diversion 180 AC/DC TIG welder, but it crapped out on me last year. I had it for years and loved it, but it crapped out. So I ended up upgrading to this Miller Multimatic 220, which has been absolutely awesome. It does AC/DC, MIG, auto sensing. It does all the things, right? And I can go from TIG, wrap up my TIG, pull out the MIG gun, hit the trigger, and it automatically knows that I'm starting to use MIG, and we'll start going through there. So I can install 2 bottles, a 75-25 and a full argon bottle, and never miss a beat when I'm switching from TIG to MIG. So this machine is a workhorse. Let's get this all tacked up and welded. All right, both tubes are welded up. My welds are getting a little better and better. Working on it. But I'll let them cool off. I'll screw the ends back on, and then we can start making the cross connects. All right, so I got all the bars mounted back up on the jig. So now what we're gonna do is we're gonna start making the inner cross bars to connect both bars. So the first bar I'm gonna make is the main crossbar that's on the inside. And this is where we're going to use that tool I was talking about, the tubing notcher that I have for my bench. So all I'm going to do is go ahead and notch this tube, set it in here, see what the distance is in between, and then notch the other tube. So this is the tubing notcher I bought that Strong Hands offers for the table. Obviously it's extremely versatile. These tubing holders can move in all these different directions. The angle, I can move the angle, and you'll see that as we make the other tubes, but extremely versatile piece of equipment. And so let's go ahead and notch this tube. There we go. I'll take this out, I'll sand it up, do the measurement, notch the other side. The 90-degree crossbar, both notches are done. I've cleaned it all up. I've got it where I want it. I'm gonna tack it in. I'm gonna weld it all the way around, and I'm gonna do the last 2 bars. One thing to note, when you're welding and you need something to stay in place, try to get as much of the weld done while it's still in your jig, because when you start putting heat into this, they're gonna expand, contract, move. It will not wanna stay in place. So try to get as much or as many tacks as you can, or as much of the weld done while it's still in the jig, because once you take it out of the jig and you start welding around, it's gonna wanna move. So let's get this burned in, and then we'll get the other 2 bars done. All right, that tube's welded all the way around. So now I'm gonna let this cool, put those back in, make sure it didn't shift too much, and then I'll do the last 2 bars. All right, so now we're moving on to the 3rd bar, the crossbar. So I have a angle finder tool I'm gonna use to make sure I get these angles right the first time in my tubing notcher. If I can get this open, there we go. So I'll just cut a tube up to length that I know will make it across. I'll get these angles and I'll start cutting it, see if we can get it to fit. All right, control arm, all done. Everything welded up. It shrunk a little bit, but I left myself enough room to where I was gonna have to use spacers, and I'll just get the correct spacers, so should work just fine. And all I gotta do now, make one more. All right, so what I'm gonna do now is build up this hub real quick. It's only an inner and an outer bearing. And this is just gonna be temporary anyway until I get my car back. Then I'm gonna switch out these 5 lugs to the 6-pin billet hubs that's on my car right now. So this is just for setup. So I'm just gonna drive these outer races and inner races in, and then press this hub in there, and we'll call it good. Races in. Let's put a little grease on these. There we go, all done. Okay, as you can see, I've got the control arm already installed on the cage. It moves freely, everything's good. So now I'm gonna put the hub on the end. Now I made these spacers to go on the inside of the hub. So, it's a tight fit. But goes in there. And then these are the studs that I was supplied. They're 3/4 inch studs that go in here. And then they have a castle nut that goes on with a cotter pin, which is perfect because now I can just put my little screwdriver through, tighten them down. Then I have these 2 little spacers.
Stop.
And now, there we go, all connected. Hub tilts. And now you can see I put the adjuster on the outside. So now I'll be able to adjust my toe without having to remove my lower control arm. Now I'll confess, I did make a control arm before all this where I had the adjuster on the inside back here. But you can obviously see what problems that would cause, because if I adjust here, that means the whole control arm is going to adjust and it'll move my hub and the control arm, so it'll move my tire inside the wheel well, which is not ideal, right? So now my wheel stays right where it is in the wheel well. The range of motion is the same. I'm just adjusting the hub toe. So this is a better design. All right, hub's installed. Both trailing arms are installed. We've made some enormous progress. I'm kind of stoked. This looks pretty awesome. This is the first like legitimate thing I've really built. So anyway, obviously we got the cage, it's all squared away. We got both lower control arms. We got both hubs mounted. I've used some welding wire. I want to get this hub at a full 90-degree angle so I can start making my axles. The way this suspension works, it's still sort of a Jaguar based suspension. So you got a lower control arm and then you got an axle that acts as your upper control arm. So what I'll do, since I have the outer stub axle mounted, I have the flanges, the bolt-on flanges for the axles on the inside. But the way these Jaguars are designed, obviously they have the brakes on the inside. And because they have brakes on the inside, I'm gonna have to make a spacer to go from the output flange to the bolt-on flange for my axle, because it's gonna have to simulate the disc still being in there, right? So I'm just gonna draw that up in CAD, print it out quickly on my 3D printer, 1/2 inch thick little spacer. If it works, I'll send it off to Send Cut Send and get me some spacers out of aluminum made. They'll be here in a week. I'll slap them on, and then, but I'll be able to go ahead and make my axles. So let's get to printing that spacer. So to print the spacer, what I'm gonna be using is Fusion 360. So first you're gonna wanna choose your plane, draw the center circle, and it's 2.75 inches, which is the inside ID. Then I'm gonna need to locate and draw out where the 4 lug holes need to go. So I'm gonna use a square, and it'll make it easier to pinpoint the points. So the top portion of the square is 2.87 inches wide, and from top to bottom is 2.42 inches wide. So that makes the basis for my square. So then what I'm gonna do is do a dimensions to the center so I can center up the square with the ID. And you'll just take half of the distance from the top and the half of the distance on the width to the center point of the circle. And basically that just centers up the block. Once the block is centered, then I can do my 4 holes, which are 0.45 inches round. Whoops, made a mistake there. And I'll set those dimensions to 0.45, make 4 of them. So now I have the basic dimensions. So now I'm just gonna do the whole surface of the spacer, which is gonna be about 5 inches round. So there we go. We've got a quick sketch of my spacer. So now I'm just gonna extrude it, all the portions I want to keep, to 1/2 inch. And there we go. We have a finished spacer. Super simple, super easy. Now all I have to do is send this to the printer and print it out on my bamboo printer. Simple as that. All right, all done. All right, hot off the press. I got the spacers made. So now I'm just gonna see if they fit. All right, they're snug, but they go on there. So now I'll I'll put the inner flange, I'll make sure this is level, and then I'm gonna measure from center to center of universal joint cup to find out how long my axles need to be. All right, that looks flush. Let me get my angle finder and make sure all this is level. Boom. Zeros. All right, close enough. So everything's level. Now I'm gonna measure from center point to center point of the yokes. It looks to be almost exactly 12 inches. Perfect, that makes it easy. I have these weld-on yokes, and since all this, the axles and the differential was out of a XJS, all the universal joints are 1410, so they're pretty hardcore. And then 3-inch tubing is what I'm gonna be making out of, DOM tubing, steel. It's 3-inch, I think it's 83 wall. I'll put the yokes on, measure 12 inches, and make me a 12-inch drive shaft. All right, I've got both ends on the tube. I measured it. It's right at 12 inches. I mean, maybe a 1/16 of an inch over, but it's right at 12 inches. So my adjustable rod ends, I should easily be able to get this to within spec. If anybody's thinking of a Christmas present for me, a press would be great. These are press fit, and I just sat here with a hammer and a piece of wood for about 30 minutes to knock these together. So if you're gonna do this, get a press. All right, let me go over there and put this in the rear end and see if it's right. I've got all the universal joints installed. We're about to test fit this sucker, see if it's gonna work. Here we go, test fit 1. I think that is about right. Let's see if that's even Steven. 0.2, 0.1, boom, perfect. Whew, all I gotta do, make one more, and then I can weld them up. Axles done. All right. It's done. We got all the axles made, lower control arms, everything's put together. The rear end is complete. It turned out better than I expected. It looks awesome. Obviously we got great range of motion. Posi track. So all the hard stuff's done. The only thing that's left now is I gotta make some lower shock mounts, but I wanna wait to get the car back and get this in there to figure out what length shock and where I should put the mount. Other than that, it's done. It's ready to rock and roll. So thanks for watching. Glad you followed along. Next week, I'm going to pick up my Futura trailer, so I may do a quick bit of video about that, but other than that, see you later.